Hello, Bio20, and welcome to our first video on the respiratory system. Today, we are going to learn about the parts of the respiratory system and how it brings oxygen into our body and releases carbon dioxide out. Today's goal is to identify the structures of the respiratory system, explain the functions of them, as well as we will eventually be doing a pig pluck activity, so you can wait for that one, and explain how alveoli moves oxygen into the bloodstream. So why is breathing important? Well, first of all, it's all about the exchanges of gases. So here's a picture of our lungs, just a little quick sketch. And our goal is bringing oxygen in and releasing carbon dioxide out. Again, why breathing is important is to exchange oxygen and carbon dioxide between the environment and our bodies. We want to release carbon dioxide out as it is waste and it is toxic to us. And we want to bring oxygen in so we can go through cellular respiration. I'm going to link this video called the breathing commercial for you to watch. So pressure. As we talk about breathing, we're going to have to consider the relationship between volume and pressure, because a lot of people know that our lungs get bigger and then get smaller as we breathe in and breathe out. But how does that happen? Well, it's all about pressure and volume. So when the volume of the lung gets higher, so when we inflate the lung, as you can see there with that balloon, as that balloon gets bigger, okay, the pressure inside the lung becomes lower because there's more space. Air pressure is pretty awesome. It works from an area of high pressure to an area of low pressure. So outside the lung, where the oxygen is hanging out in that picture, is now an area of very high pressure. So what ends up happening is air wants to move from an area of high pressure to low pressure. So it rushes inside the lung due to the changing of the pressures. The same, and please make sure you draw this picture in box A of your notes. The same can be said for exhaling out. The opposite is true. So when your lung is full of air, now the pressure is really, really high inside. So what needs to happen is the air needs to move from high pressure to low pressure. So it goes from inside your lungs to back outside your body. So this picture here is picture B, and it just shows a deflated lung. So this is a little diagram that shows how balloons can mimic lungs. And essentially that rubber band or rubber material on the bottom is inflating it by pulling it down, changing the air pressure from the inside to the outside. So inhalation and exhalation and how we breathe. Here's just a general diagram. In inhalation, we want to use our diaphragm for the whole idea of breathing. Now, we're going to talk about the diaphragm contracting and relaxing, and it is key that you guys memorize what the diaphragm is doing. So inhalation means we're bringing air into our body. And when we do it, it contracts the diaphragm. So the diaphragm moves down. Now the diaphragm is that lovely U-shaped muscle located just underneath your lungs. If you grab your ribs and run your hands along your ribs along the side of your body to the front of your body where your ribs meet, that's where, right below where your rib cage is, that's where your diaphragm sits. Okay. When you breathe in, your diaphragm pulls down. And what actually ends up happening is those ribs that you can feel, if you put your hands on your side and breathe in, you can almost feel like your lungs inflating because your ribs start to move up and out. And that's due to the air pressure. So again, as air pressure gets bigger inside, our lungs inflate. Well, our lungs can't inflate if they're enclosed in a hard case. So what ends up happening is our lungs actually have a set of muscles in between them. Not our lungs, our rib cage, has a set of muscles in between them called intercostal muscles that help the ribs move. So when we inflate our lungs, we have space. Exhalation is the opposite. Our diaphragm relaxes and pushes back up underneath the lungs, pushing the air up and out of our lungs out to the outside. And again, our muscles then relax along the inside and our ribs return to normal. So air pressure in the chest cavity, if you could have read what it said down there before I accidentally moved my mouse and it covered, but air pressure in the chest cavity and lungs is low because gas has to flow from high to low. So as it moves from in to out, it's low in the inside until we inflate our lungs, and then it is high. So oxygen in the air is vital to cellular respiration, as we already know, and carbon dioxide has to be removed. So as a reminder, that's just the uh, equation for cellular respiration. And it's just reminding us that it's important that we need to bring oxygen in to produce carbon dioxide. So here's some interesting facts about the lungs. The lungs are the only organ in your body that can actually float on water. And that's simply because it's got lots of little air pockets and it holds air all the time. And so what happens is when you put it on a glass of water, it's less dense than the water, and so it floats on the top. You breathe in about 6 liters of air every minute. So if you think about drinking 3 2-liter pops, that's how much air you bring in 1 minute. Your right lung is actually bigger than your left lung because you have to accommodate your heart. And the surface area of your lungs could actually cover that of a tennis court. So they have about the same surface area size. This is just a flow chart, missing maybe 1 or 2 steps, but it's just a generalized flow chart of how air passes into your body. So air has to move through your mouth or your nostrils down into your trachea. Now, before I even get to that, there's a few pieces in there missing. The reason I have them missing is because you haven't heard about them yet, so I didn't want to confuse you. But air, mouth, nostril, trachea. Trachea is the cartilaginous tube that you can feel kind of just in your throat. That's your larynx, and then your trachea starts just below it. Okay, and then you have from your trachea to your bronchi to your bronchioles over to the alveoli. But we want to define and explain all of these pieces. So now what we're going to do is we're going to label the diagram of the uh, respiratory system. You'll notice that I added the letter N into this is because we're also going to talk about an extra piece that's not listed on your diagram. So if you could just add it. So we're going to start here with A and L. Why? Because I accidentally did it that way. So A, if you look at A, it's over here on this thing. A right here is a capillary. Okay, a capillary is a very, 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 very tiny blood vessel that allows blood to flow through it in single file. So one red blood cell at a time. So think about when you were in middle or elementary school and your teacher made you line up at the door and walk through the hallway single file. That's how blood goes through. L, which is all the way over here, is a bronchiole. And we'll talk about what all these are and their functions here shortly. B is known as an alveoli. So that's this little like grape looking sacs here. Okay, those are alveoli. Alveoli are where gas exchange happens. And M on the big diagram is your diaphragm. C is your oxygen poor blood. It's coming from your body and it wants to be filled with oxygen. So we call it oxygen poor when it doesn't have any oxygen left in it. And N, the one that you added in, is called the pleural membrane. D is oxygen-rich blood, meaning we filled it with oxygen and now it's going off to the body to pass on oxygen all around. E, starting at the very top, is your nasal passage. F is the pharynx. G is your glottis or your epiglottis. And H is your larynx. I is your trachea. And J is your bronchi. Then we've seen L, M, and N. I forgot. Oh, J, K is your lung. I forgot K. So that is all of the parts of the respiratory system. You will have a drawing quiz that you will have to label these. So please make sure once you've labeled that you practice and learn all the names and the functions. So let's talk about functions. It's big, big chart. So you might want to pause the video and copy it down now or listen to me and copy it down after. So the nasal passage. The nasal passage, when you breathe in through your nose, actually the function of it is for defense. It's covered inside with small hairs called cilia that actually help trap bacteria from the air and dust and particles and stuff. Trap it in the hair, and that's why you sneeze. It tickles the inside of your nose, which sends an impulse to your body that says, you need to sneeze this out. You don't need it. It also warms the air as it moves from the outside of your body to the inside. And there's also a lot of mucus that lines it, hence how you get snot, okay? And it also traps foreign objects. So that's when you blow your nose, you're trying to get rid of those foreign objects out of your nose. The pharynx is found right after that, and it essentially connects your nose to your mouth. So you can breathe in through your mouth or your nose, okay? But the part where it connects is called the pharynx, and that's where your tonsils are actually located. The epiglottis is found just a little bit lower, and it's like a cartilaginous leaf-shaped flat flap, and what it does is it actually acts as like a lid to the larynx. So the pharynx happens first and then the larynx. And what it does is that is kind of the way that it's like a directing traffic essentially. It stops food from entering your path airway. So when you take a sip of water and you say something like, "Oh, that went down the wrong tube," what you're actually saying is you accidentally swallowed it and it tried to go down your trachea instead of down your esophagus. Your larynx is right at the front. It's a part of your throat you can see. Okay, you can push on it a little bit. It's a cartilage. It feels bumpy because it's made out of rings. It's also where your voice box is located. And for boys, it's where their Adam's apple is because there's two pieces to it. And right where the two pieces meet is where the Adam's apple is. It's also where your thyroid gland is located, which we will talk about in Bio 30. Your trachea is essentially the rest of the airway from your larynx down into your lungs, which is a long tube that is lined with mucus, again, to help stop bacteria from entering your lungs. Then we reach the bronchi. The bronchi then are the split from the trachea because you have two lungs, so you have to send air in two directions. So it splits in almost like an upside down Y shape. And again, the bronchi's job is to moisten and clean the air as it enters the lungs. Essentially, the whole way through, you just want air to be clean. You do not want bacteria getting in. That's how you get common cold or bronchitis or pneumonia or stuff like that. So you want to try and clean the air of any bacteria or foreign objects as much as possible. Your bronchioles are tiny little narrowing tubes that branch off from your bronchi. Essentially, we don't want these big tubes rushing down to alveoli because you have tons and tons and tons and tons and tons of alveoli at the ends of your bronchi. So you want really small little branches that reach the alveoli that air passes through. So think of like big branches on the tree being the bronchi and all the little tiny twigs coming off those branches being the bronchioles. So then once I'm going to skip pleural membrane, I'm going to move to alveoli. So once you've reached through the bronchioles, you reach the alveoli, which are essentially the small air sacs at the end, which was B on your diagram. They are at the end of the bronchioles, and this is the most important part of your lungs. It's the site of gas exchange. It's covered in tons and tons of little tiny capillary beds or capillary sacs, and they exchange oxygen and carbon dioxide all the time. Now, the three kind of outside of your lung structures are the pleural membrane, the diaphragm, and the intercostal muscles. Your pleural membrane actually lines the outside of your lung. It's a thin lining of the lungs, and its job is to keep it moist. Okay, so you want to make sure that you have it moist so that it slides and that you can do good gas exchange. The diaphragm is a large muscle underneath your lungs. Okay, so we have already kind of alluded to what that does. It contracts and pulls down whenever you want to inflate your lungs, or it pushes and relaxes back up right underneath your lungs when you exhale. And lastly, your intercostal muscles are the ones I've already talked about as well, are ones that are found in between your ribs. They essentially help your ribs move up and down when you're breathing in and out. So ladies and gentlemen, please make sure to know your picture and to know the functions of the parts listed in your picture, as we will have a drawing quiz soon.